Hello, welcome to another episode of Let's Make It. This week, I'm here again with Bob, and we have some special things going on this week. Bob's going to do some special things for us. But before we get started, let's make sure we say hi to Bob. How's it going, Bob?
Good, Mike. How are you?
All right. So how's your week been?
This last week has been painfully busy, so
How busy?
I'm looking forward to a little quieter week this week.
Yeah, it's busy's always good though, right?
Busy is good, but overloaded is not so good, and that's where I've been this week. So,
Yep.
a lot of 12 and 14-hour days.
So I do have something here I want to show you. I know you're still waiting for yours, but here is 5 different board sets right here.
I'm jealous.
And there's 4 boards of 5 different projects. So these are like the prototype boards, make sure they work. But are also got from another company 2 other shields that I got more made of. So haven't put them any together yet. So that'd be maybe in the next couple of days. Although I'm getting ready to travel a little bit, so through the next weekend. So I'm not sure how far I'll get with them. But I also got all my surface mount stuff too. So I'm going to try some surface mount baking. I guess you want to call it.
I'm jealous. I'm jealous. You have new toys to play with.
Yeah, we'll see how well they work. I haven't tested any of them yet, but they should work. They should be fine. There's one of them that actually I saw a mistake that I made, but it should be easily correctable. If one run didn't make it, but I can jumper it to make sure it's going to work okay. So before we go too far, this is our last week. We're going to actually sit here and come and get everybody to go switch to YouTube. So I checked a little bit last night. We're a little over 1,000 subscribers have moved. A little over 1,000 have moved over to the new channel, but the old channels had more than that in it. So I don't know if you add them all up, they all had more than that in it. So I don't know if we get people subscribing to multiple channels or whatever. But this is the last week. So if you're watching this on the old channel and it's not youtube.com/TechZenTV, then you need to go and switch over, because next week this show won't be on the old channel anymore. So this is your final notice to go get moved over. So no more nagging, everybody. We won't be nagging you anymore to go to the new channel. We also want to remind you this show is recorded 9 p.m. Eastern Time every Monday night, and it's recorded live. So that means you can come, get in the chat room with us, and actually talk to us pre-show, post-show, during the show, anytime. It's been quiet, so we're trying to get that built up. Although we get a lot more. I sent an email to Bob today from one that I got, and I got 2 other ones this week I haven't sent you, Bob, because there are questions about shows that were prior to you joining us, and they're asking for some questions about some of the code in it. So I answered those. I'll forward them to you so you have a copy of them. But so we're starting to get a lot more interaction with people, and that's growing. That's good. I also took a look at our downloads. So we've been getting an average of about 16,000 views a week. So we should have a lot more interaction with people with 16,000 views a week. That's between the downloads and the plays on YouTube. So definitely come.
Yeah, and I've actually had been one of the emails that you sent me that we got on the show a couple weeks ago. I've been having a running conversation with a gentleman working out his circuit, and it's actually a very interesting circuit that he's working on, and I haven't talked to him about it, but he may be interested in letting us use it on the show sometime.
Or you can bring him on the show and do it.
Maybe. It's an interesting circuit that he's working on, and he's using some interesting parts that I haven't seen before, and it's an interesting project. So
that sounds like fun.
We do email back and forth.
Oh, that's good. So yeah, but we'd like to have you interact live if you have the time, if you're around at 9 p.m. I know the email I got today was actually from somebody in India, so I'm not sure what time we'd be there when we do the show live. So I don't know if they actually could actually watch us live or not. But yeah, if you can come and watch us live, we would like to have you here. We'd like to have you in the chat room with us. It's definitely nice to have people in here to chat with. All right, so this week Bob has he did a presentation this past weekend. I'm gonna let him go through that, but he's going to give us the presentation and also show us the circuit working as well. So you ready to go, Bob?
Yeah, I think I'm ready to go.
All right.
This is a presentation that I did over the weekend. It's on multiplexing and timers and the persistence of vision that you're taking advantage of. So if you'll give me just a moment to turn off the camera and switch to my desktop. So I'm just going to go through this presentation as I did over the weekend. And you should, if the technology has worked, you should have.
Voila.
You have it. Excellent. All right. So this presentation, it's on timers and multiplexing. And in the actual demo, or in the presentation, I actually started with a video of the circuit and asked the question, if I told you that each digit was flashing 250 times a second, would you believe me? And of course, most of the people, they couldn't believe that. They couldn't believe that a LED display could turn on and off that fast and actually appear like it was on, even though it really wasn't on. Well, the point is that's thanks to multiplexing. So in this presentation, this is what we're going to talk about. Multiplexing, persistence of division, timers, and for this audience, I will tell you right now that the timers, we're going to stick to a very high-level view of the timers, although I do have one place where I show a real nice website that if you're interested in low-level interrupts and actually controlling them all yourself, I give you a nice website where it'll calculate those interrupt codes for you. But for this, we're going to stay high level, and eventually we're going to use the Timer 1 library that's on the playground. So here's the so this is what we're talking about. We're just flashing things so fast. So what is multiplexing? Well, let's say, for example, that we have this 4-character display, and to control this, if we weren't using multiplexing, we'd have to use 32 I/O pins, because each one of those segments has there's 7 segments, and then the decimal point that I don't actually show right here, but it is the eighth control. So we'd have to have 32 I/O pins, which of course an Arduino doesn't, or an Uno doesn't have. So we're stuck there. So if we go to 4 shift registers and 32 resistors, we could actually get it to work with an Arduino. So here's what the circuit looks like. And for this, I've actually left out. I've only connected one of the 4 LEDs. And if anybody watched the show last week, yes, this was actually done in fritzing. So these are fritzings. That's where the F comes from. But for this, I've left out the connections for 3 of the LEDs, because there's just too much noise. There's too many connections, too many wires. It's confusing, and it gets in the way, and you just can't tell where anything's at. So to help get the hardware down, we're going to, instead of connecting everything directly, we're going to multiplex it, which makes a simpler circuit. And here's what the new circuit looks like. So we have 1 shift register, and then we have 8 lines. And then instead of, and in this one, you can tell that the NPNs are actually controlling the cathode side, and the shift register is controlling the anode side. So we end up with 8 resistors and 4 LEDs, but now we've taken out 3 of the shift registers and we've put in 4 transistors. So we have a simpler circuit that we're working with. So what does multiplexing look like? Well, we're going to go back to our same 4-character display, and this was the question. This goes back to this question right here goes back to where we started, which when you look at this, you'd think that every digit is on, that you're actually looking at 1, 2, 3, 4. But that's not what we're actually going to do. Instead, we're going to turn on the 1, and then the 2, then the 3, then the 4. And then we're going to start going through this a little, for this demonstration, we're going to slow it down, but we're going to repeat this process over and over again until it's fast enough that you can't actually see the flashing. So this LED display actually looks like it's on, even though it's actually flashing really fast. So if we go back to the circuit, what's actually happening is you're loading data onto the shift register. You're turning on one of the transistors. So the cathode is now connected to ground. You turn on the display for a short period of time, then turn it off, reload the shift register with data, turn on the next transistor, and then repeat the process over and over, where loading data, turning on a transistor, and you're doing it over and over and over again. But instead of dealing with in time frame, seconds and minutes like we're used to, this is all being controlled at the microsecond level. And if someone isn't familiar with microseconds, that 1 microsecond is a millionth of a second. So why does all this work? All this works because of a concept called persistence of vision. Now, the term persistence of vision actually isn't accurate. And I found this real interesting. I knew the term, but didn't know where it came from until a couple weeks ago. Originally, people thought that persistence, that when you looked at something, the image persisted on your retina. And of course, now we know that what's happening is that the human eye and our brain is actually processing about 20 frames a second. So you look at something, your brain grabs it, processes, and it's happening roughly 20 times a second. And if we're watching a video or something that is less than 20 frames a second, it actually appears. So I found this little video that's going to come up in just a second on Wikipedia, and this is actually the animation that they show on the persistence of vision page, and I couldn't find anything that shows this better. So when we watch this, what you're actually seeing is a picture that is 12 frames a second. So when we look at this, we can tell that it's jerky and that it's not fluid. It doesn't flow properly, and it doesn't look right. And we can recognize without even realizing what it is that it's not right. So, and this concept about persistence of vision has been used for the last century in television and film. So for most of us, when we watch TV or go to the movies, we're watching somewhere between 24 and 30 frames a second. And now, of course, there are some televisions that are coming out that are showing their a frame rate faster than that.
If you're watching 720p, it's 59.94 in the United States and 50 in the Europe.
That's right. But for standard TV that you watch, you go to the movie, this is what you're getting, the typical 24 to 30. So what I did, this next little video that I made, this is actually the demo circuit, and And in the second half of this presentation, I'll show the code, but I don't actually have it loaded on the Arduino right now. But we're going to go through what the frame rate looks like, and we're going to run it from 100 to, or excuse me, from 1 to 100 hertz, and you can tell a little flicker at 100, at 50 and 100, but in reality, that's the camera. If you're looking at the circuit live, you can't tell that that anything is flashing at you. So let's play the video. Uh-oh. Maybe we're going to play the video. There we go. So here we have 2 hertz, then 3, then 5, there's 50 hertz, and it looks pretty much correct, and there's 100, and you can kind of see a little flicker in the video, but that's actually not there in real life. So here's kind of the summary of it. Multiplexing works because it's consistent. It's the update is predictable, and this is where timers come into play. And this is where I stopped and answered questions. So actually, I'm trying to think of one of the questions that I got asked over the weekend is when someone looks at their alarm clock or an LED display in a store, is this what they're seeing? Is a multiplex display? And the answer is for an alarm clock, maybe. For a display at a store, probably so. One of the great advantages of multiplexing is that your power usage goes way down. When I was doing the math on mine, I'm at less than 10% of what if I were to have the LEDs full on all the time. I'm at less than 10% for really no appreciable reduction in intensity of the LEDs. So did you think of any questions we might answer here, Mike?
No, so you're not going to go through the timers in great detail, right? I mean, there's different kinds of timers, and I think we might want to, at some point, at least maybe not now, but in the future, go through those. Yeah,
and in a follow-up show, we definitely can go through low-level, manipulation of the timers. I do. That's actually where I go next. Is the Arduino does have timers available. And we'll just skip ahead. So we're gonna just so everyone knows, we are talking about the Uno specifically. The Mega does have 1 or 2 additional timers. I'll have to go back and look. I don't remember, but we're going to talk about the Uno specifically. So the Uno actually has 2 types of timers, and we've talked about the PWM, the pulse width modulation, on a number of occasions. and of course they are labeled on the labeled on the Arduino. You can tell which one is where. Which one's a PWM pin. And in reality, these they actually run at roughly 490 hertz. And then, of course, there's the 3 built-in timers, software timers, that are timer 0, 1, and 2. By default, timer 0 is used for the delay function, the millisecond function. Timer 1 is used as part of the servo library, which you've demoed at least twice, I think.
Yes,
Haven't
twice.
You?
Yep.
Okay. And then timer 2 can be used for the tone function if someone's creating an audio tone. And then here we have just a general, actually that is 60 hertz, not 30. This kind of gives folks an idea of what is the range. And this is, for a lot of things I've done, timer 1 has been what I've used because although it's got the smaller range like timer 2, it's got a much wider number of steps that are available. So you can more precisely dial in the speed that you're looking for.
Right.
Sorry, had to cough. So here's kind of a long-winded, give you an idea. Basically timer 0 and 1 are 8-bit, and timer 1 is a 16-bit. So there's a wide range of frequencies that you can calculate when you're working with the timers. Now this next slide that is coming up, I do have this website that makes it really easy to calculate the interrupt codes if someone is interested in them. But for multiplexing, that demo we looked at a little while ago, 100 hertz did very well. And when we switch to the camera, when we go to the live circuit, I've got it running at 250 right now because I actually have one demo that runs so fast that you've got to have a slightly higher clock speed than 100. But if you were just displaying text and numbers, 100 would be fine. So that website, this is what you see, and it gives you the interrupt codes. On the left side, you put in your clock speed, the frequency you're looking for, and it calculates the interrupt codes for you. So I'm not going to go through this in detail because we're not going to go into the low-level programming. We can do that on a future show if folks are interested. But for right now, we're going to stay high level, and you're going to use the timer 1 library when we switch over to the demo. So, and that was pretty much it. Multiplexing, persistence of vision, and a range of timers that are available to implement the the multiplexing. They're all there. So
okay.
And then of course at the end, here's all the references and where I got things and the Wikipedia page and data sheets. It's all on the last slide, and I don't have it on the show notes yet, but it'll be up there.
All right.
It'll be up there.
Great.
soon. So any questions that I didn't answer?
I can't think of anything off the top of my head.
Well, good. That means I covered everything well.
Yeah, I do think in the future we kind of need to go through and probably do something with timers. A little bit more with timers than what we are right now. I mean, I think it'd be a good thing that we discuss in greater detail and just in this and using it for multiplexing, but the different timer options. And I didn't know the Mega. I just looked it up. The Mega has 3 more timers in it. I didn't know that.
Yeah, and for the audience that that this presentation was designed for, high level timers was what I needed.
Right.
But yeah, we can go into low level timers. It's that I think it's fun. Although the timer one library sure does make it easy, and let's face it, I can be pretty lazy sometimes. And why do something when somebody else has already done it for me?
Right. So while you were doing that, I don't know if you were watching what I'm feeding back to you, but did you see the little blank go through the screen a couple times there?
Mike, I think Skype is failing us again, and I'm having an audio problem again.
Okay. Well, I'm having a bad storm.
That may be it. So
that's why things were flickering. If people are watching on the stream. Yeah, we've had two close lightning strikes. It scared me because I don't hear anything back in this part of the house, but my microphone picked it up and it scared me. So,
well, I haven't heard the storm, but
is the audio back to normal?
No, you're still breaking up pretty badly.
Okay,
well,
you're still
for you.
Yeah, you're still good on my side. So if you want to go ahead and keep going with the demo, that works.
Well, once again, recording live has
yep.
something has happened. So
3 weeks. It's 3 weeks in a row for us.
Well, this was the halfway point for me, and this is where we paused for a little while. Shall we go into the next one, or did you have something for the break?
Nope. Go on. We'll try to get through it before the storm catches us.
Okay. Well, for the I guess just so well, let me just so you can see. I did do just a quick presentation, just a couple slides that really this is what we went over. So review the schematic, and yes, this was done in fritzing, and we can talk about that briefly. And I've got the circuit running here, and you will quickly take a look at the timer one library, and then of course we'll kind of walk through the demo code. And for this audience, a lot of the code is actually very similar to what I've done in the past. So some of it will look familiar to you. So, okay. Well, Mike, I think I've lost the audio completely now.
No, you're good.
I'm getting only bits and pieces, I'm afraid.
Okay.
Very few bits and pieces.
Are you in the chat room? Yeah, go ahead.
Okay, I'll go ahead and continue. All right, so here is here's the circuit, and it's actually running. I've had it running the test code tonight. So, okay. All right. Wow. Okay. That's a little clock sequence that I came up with, and while that is running, I'm trying to get fritzing back up. Okay. All right, so let me switch back over to my desktop. So this is what the schematic looks like. Now, this schematic is actually drawn for the board that I've been waiting for 2 weeks now to come from China. The board is designed for. We've got an Arduino, and it's actually designed for 8 transistors. Although the circuit I've got on my breadboard is just running 4. And then I've got the Maxim 6971 chip that we've demoed before, and I've got the 16 out pins for each LED, and then the cathodes are all connected. Or in this case, I'm sorry, the anodes are connected to the transistors because the Maxim is a sync driver, so it's controlling the cathodes. But it's a fairly simple circuit, and when I actually get my board, let me switch. Here's what my board actually looks like. So hopefully next week I'll have the board and I'll have one assembled because it's going to show up in the next couple days. But there's the board and there's the schematic that we're using. So fairly straightforward. 1 chip, 8 NPNs. So pretty easy to. It's not a terribly complex circuit. Okay, so let me.
Has your audio come back yet?
Okay, here is. All right, so here's the code. Trying to see the code. There we go. So we've included the timer 1 library, which is it takes care of all the high level functions for you. And in reality, it's there's only 2 lines of code where you tell the timer 1 library to do anything. So, and for most of it, I'm not going to go over this in a lot of detail. The things that are interesting, I do have this in here because the Maxim does support pulse width modulation, although I'm not actually doing anything with it. But for the circuit and the circuit board, I do have it connected, and we're going to just set it, and then we're never going to touch it again. And then of course I've got my four NPNs that we're turning on and off. So the rest of this is actually very familiar, and if somebody watched the show previously on 14 segment displays. Well, here's all the code, just like, or 7 segment displays, excuse me. This is all the same kind of setup where I just want to show how do you put the pieces together of the displays, and then just some arrays that make things a little more convenient. And then here's the 2 lines. Well, let me back up just a little bit. In this case, I created 2 variables. One of them is the timer variable, which is, in essence, tells the library how long do you wait between interrupts. So in this case, I'm setting it at 4,000 microseconds. So every 4,000 microseconds, it's going to go to this function right here that I'm setting in attach interrupt, and it's going to go run that code. So I just created that variable, makes it a little easier to read. And then of course I put in some values up here for various timer speeds. Sorry. And for this, we're using 250 because it works out. It displays nicely in this configuration. And then the second variable is I have this MS delay, and that's a microsecond delay, and that's actually the time that a display is on. And we'll see that later on. So one line, we initialize the timer and tell it how often to run, how quickly to run, and then we use this attach interrupt function, and we tell it what function, and I have the function out bytes at the end of the code, and that's what's running every 250th of a second in this demonstration. So the rest of the setup is fairly straightforward. We set our pins, set our NPNs low so everything is off. We clear the 6971 chip, and here, now I've got it commented out here, but that multiplex examples, that's from the video that I showed earlier. And then here's the 14, well, and then all the test code is contained in there. And if you go back to some of the other code that I've done in other shows, it would actually work. That same code would work in this file. I'm just not using any of it. So, okay, so continuing multiplex examples, this is where I'm cycling through the various speeds, and it's a very straightforward, I'm just displaying whatever number is in the demo times, and can just to show what the different speeds look like. And then 14 segment tests, I go through the various tests, and I get a plug-in for the show, of course. But here's where, the rest of this is fairly, we're just going to skip through it because it's really not, it's just displaying to the 14 segment displays. This is where, now for people who have watched this before, you may have noticed this function that I had, S-delay. This is a delay that takes in consideration an interrupt. So rather than just the regular delay function that comes with an Arduino, I wrote this S-delay, and in this version I actually added, it's actually aware of switching to microseconds versus milliseconds. So, and that's what, here's the milliseconds, here's the microseconds. So, and according to the information that I found on the playground, as if you're under it was actually 16 milliseconds, then microseconds works. But if you're over 16 milliseconds, then microseconds, it's pointless. The timer is at the counter that's actually being used doesn't count that high, so it doesn't work. But this actually is aware, and as soon as you hit whatever time you're looking for, then it kicks you back to the function that that it called it to begin with. So this is the out bytes. This is what's actually running in my demo 250 times a second. So, and I've got it. There's two different ways of running this. It's actually aware of whether you're doing it in digit mode or where everything is displaying the same information. So when you're displaying in a digit mode, and I'm going to skip it. So you turn off the latch pin so you can load the data. You load your data, and this is the same basic code that we've used before. We write it out, and then we turn the latch pin back high, which so the chip is now on, and then we go to the first transistor, turn it on, wait for the specified microseconds that we set back at the beginning of the code, and then we turn it off, and then we go back and do it again. So just what we were talking about before, you load your data, turn on the transistor, flash for a short period of time, turn it off, go to load the data for the next one, and flash the data. The second half of this function, where all the digits are actually exactly the same, is basically the same. We're loading the data in, and then we're just running through this for loop of turning on the transistor, waiting a specified time, turning it off. So the chip itself is only loaded one time, and the transistors are cycling 4 times. But they're all turned on and off at the same for the same amount of time. So, how is the storm, Mike? Can you
hear me now?
You're still breaking up.
All right.
So,
what else do you want to show?
I missed that. I'm in the chat room.
Yeah. Do you want to? What else do you want to show?
Okay. Let me. Well, I think. Oh, I'm sorry. Wrong button. I think the multiplexing in action. This is it, and it's a little change in circuit design and fairly simple code. I mean, that's why personally I like the Timer One library, because it makes things very easy. One note of caution in the code, though, you do have to be careful, what delay you put in there, because if you're programming this, you have to be aware of, okay, this function out bytes is going to be called 250 times a second. That means the code has to finish before the next interrupt cycle comes around. So it's really easy to lock up an Arduino if your interrupts are running on top of each other, and then you just end up with whatever the last thing was that was displayed, and it doesn't work. But it's easy to fix. You change your code, re-upload it, and Arduino picks it up. Right. you don't kill your Arduino or anything. So that's pretty much it. We've
all right.
Shown the circuit, shown the demo, real code. It's actually real nice to. It's a nice library, and multiplexing definitely. The big advantages are that it's a simpler circuit and lower cost to run, which is for what we're doing. That usually the cost of electricity really isn't a big factor for us.
It's such a little amount there.
A big display, then you could make a big difference.
Right, exactly. All right, so you still can't hear me very well, can you?
Yeah, you're breaking up badly again. I guess the storm is getting us.
I don't know if it's what it is, because I checked the bandwidth while you were doing your thing, and I still have 9 megabits up and then 39 down. So I don't think it's the storm. So all right, well, we'll just struggle through. We're almost done. So. Okay. You can't hear. He's in the chat room.
I can't.
In the chat room.
I'm getting maybe a tenth of what you say right
Okay.
now.
All right.
So I'm sorry.
That's no problem. I can finish up. We hear you fine. So we can understand everything you're saying. But I'll go ahead and I'll finish up. Because we're pretty much done. That's what we wanted to show you this week was the stuff that Bob had worked on over the weekend, and he had presented this, and we've had questions about multiplexing in the past, so we kind of held off until he could do this. So thank Bob for spending all the time on and running the show tonight. Sorry for any technical issues. I know there's a couple times there where the screen's come on blank and came back. That's when I was having power blinks, and my matrix was rebooting itself every time that happened. I don't know why. And everything else set up with the UPS, but for some reason it didn't. So sorry about that, but we can't help out what Mother Nature does to us. It's just another week that we had some technical difficulties, which is part of the fun of doing a live show. So that's why you come watch us live. And we do want to invite you every week to come watch us live. Also, we are re-pushing the Facebook page. We have a fan page, facebook.com/TechZenTV. Go there and hit the like. We've been running this for a couple of weeks, and the likes are going up, so that's a good sign. I don't know where we are. I haven't checked it for a couple of days, but go do that. As well as on Twitter, we are now starting to use hashtags. The hashtag for the show is Let's Make It, and you can tweet out Let's Make It on your Twitter, and we do kind of watch those, and we kind of get some feedback on that as well. All right, again, we record live this show every Monday night at 9 p.m. Eastern time, and you can come watch us live. You can get in the chat room. Bob and I have been chatting in the chat room tonight because he can't hear what I'm saying back to him. It's breaking up for him. So can you hear me enough to say goodbye, Bob?
Good night.
Yeah, night. You heard that part, right?
Well, I got enough to know that you were telling me good night. So.
All right. Good
night, everyone.
Good night, everybody.